Hey everyone, we are
Hi
we are back.
everyone.
Time for some more fun. It's potentially going to be another week of will this work or won't it? Which is kind of par for the course, it seems, for the last couple of weeks.
Yeah.
I think it's just playing with music, buddy. Oh
Uh,
no,
the music should
you
be
might want to
off.
turn the music off, Jacob.
I did turn it off.
Ah, right, all good. Sorry about the confusion there. I just was like playing it on YouTube and the music was still playing right at the start. So, man, that's how organized we are. How many hours ago did we start prepping for this, Jacob?
Uh, Less than one.
Less, yes, sadly. Um, Continuing on from last week on our exploration of figuring out how. I don't know. We haven't actually gotten to any proper reversing of malware yet. We're still trying to like reverse engineer like the loader
Yes.
script, the thing that, or the stage or whatever it is, that the thing that's trying to get the malware installed. So what did we do last week? So we talked about a little bit about as far as where aware best practice for setting up a reversing environment. So doing it on a separate computer from your daily driver. Ideally, that thing is on a different like network segment to the rest of your stuff. So easy ways if you've got like a guest Wi-Fi network at home, as
Yep.
well as a normal Wi-Fi. Like some routers just come with that configured. Connect to that, and then run a VM on that computer on top of that, so that well, you get the nice VME features like being able to restore and stuff like that, like Jake was just doing, because there was some issues with something because we have learned a bit more about how this thing runs. Oh man, I've said like less ums, and I just went Oh, I got to make it like smoother. And I
Smooth.
just did an R. So, uh,
So yeah, last week we set up a VM. We
installed
disconnected
Visual.
it from the internet. We set up Visual Studio and Wireshark, which are the two tools that we are sort of interested in for this application because it is a VB script and Visual Studio can debug a VB script. And because we think it's going to connect out to Phone Home, we also installed Wireshark so that we can try and capture the packets for that.
And then
Then,
and
sorry.
then we started trying to actually figure out what this script did. So it looks like it. I know you can't really see anything on the video at the moment, just hearing our dulcet tones. But we then set up Visual Studio to use like debugging through C script. C script's just the kind of scripting runtime on Windows. I think there's W script as well.
Yeah.
And so trying to figure out what this thing does. So it looks like it's all obfuscated, and there's some stuff that decodes some other bits and pieces, and then runs that.
Yeah.
There is some other stuff we learnt, and then also interestingly enough, we have found that it looks like it does spin up like an SSH server and create a whole different user, which
Yeah. So
was
it does do a few interesting things sort of in the little prep time that we had. We found a couple of things that we are going to sort of keep an eye on. Oh, no. Maybe it's this VM that has that.
oh, unless wait, when did you recover to though?
I recovered to before I ran this.
Okay, that is interesting then.
Have you installed the IEVMs yet? Any of them?
I don't remember an SSH user being on there.
Neither do I.
What's the username? SSHD server administrator.
Yeah.
It's an interesting one to have on. Nothing shows up on a Google for it. So interesting. Anyway, maybe we'll figure it out. Maybe we won't. We'll just keep
Maybe
on
we
going.
might. Yeah.
It isn't. I wouldn't think there'd be an SSH server on the base VMs.
I wouldn't have thought so either.
Anyway, Does it have when it was created or installed? Because it does look like it could be
part of the VM.
Yeah, if you go right-click properties. If it's January 13, 2015, maybe it is. Why would you have... Oh, maybe for automation or something. Anyway, okay, ignore that then.
Ignore that. We thought it was
That's
part of the
our,
malware, but it's probably not.
That's how quality work. Anyway, back to this. So Jake's just setting up some breakpoints. So this is the script you get. Obviously, as you can see, it looks like garbage. That's because I don't think someone would have done this manually. I think you can get things that'll go and munge up. So like you get with JavaScript minimizing, which kind of compresses everything down and makes it a lot harder to read. All you can do is derive what it does purely from following the logic. There is no useful names and variables, no comments, and it's layered functions inside functions and things that seem to do absolutely nothing, and massive chunks of these like G9, E8, O2, which are the names of variables that are later on, and there's just numerical values assigned to those variables, which turn out to just be Unicode. So all it's doing is decoding the Unicode and then using that to then run queries.
Yeah, so we went through a couple of these functions last week, trying to follow through the process of what it does. I was hoping to run through this process off stream so that today we could be reversing the binaries that it downloads, but I didn't get a chance to do that, so we might try and do that on stream instead.
Instead, we played Elite Dangerous.
This is true. Instead, we played Elite Dangerous on the weekend.
Man, we are diligent.
It's funny because, when I said I don't know what to stream, Z said, let's just stream Elite Dangerous instead. Which could have been funny.
Elite Dangerous. It is fun, but it's probably, I don't know, maybe it is just as interesting as a security stream because
probably.
I mean,
anyway, so yeah, I guess what we were talking about with stuff that's useless and stuff that's not necessarily, if we look at these first, damn it, I just noticed that I said it. If we look at this first function, we can see that it's getting assigned to this variable here. And when we look for that variable to see if it ever gets used anywhere, go find all, we can see that it doesn't get used anywhere. So essentially all of this runs and does nothing. If we go down to the next one, we can see straight away that it's already found it somewhere else. So this one does actually get used as part of this new array. So there's quite a few of them that do get used, but not all of them do. And that's part of the obfuscation and throwing you off the scent, because you don't necessarily, or you can't necessarily delete all of these, or the app will still break. So we need some, but not all.
Obfuscation in scripting language. Actually, maybe we should talk about at some point near the end of the stream. We both had a bit of fun creating a little reversing challenge ourselves. But the challenge with scripting languages is it's all sleight of hand to try and hide what you're doing. So dummy functions, things named weirdly, switching the values of variables around, just dummy things that do nothing. Exactly. Whereas in a compiled, once something's compiled, it becomes inherently a whole lot harder to figure out what it's doing, which is why in something like this, you would then mangle all the names to make it harder to follow the logic in the similar sense as what you do if you just reversed assembler, or, whatever low level thing, or Java.
Oops. Let's run this. So,
which, again, apologies in advance, can make for a less than interesting stream as we figure out what this thing's doing. But
I guess the next step is to start listening. So I guess let's just listen on this one, which should be this one. Let me just confirm it's called 3. Yeah, cool. And so this is what we were talking about either putting it on an isolated network or just not having it on any internet connection. And we can see that it has paused on our first breakpoint, which was our useless function. We've been through a lot of this already, so I'm just going to skip over a lot of this until we get to somewhere interesting. And so this is the variable that we can see is using a lot of those other variables from up in this massive chunk of assignments. And pretty much this just creates a massive 2D array of Unicode characters, which if I can find where it went, I'll just F11, there we go. So it skips over, all it does is assign it, which I can see down here. It started with D, so it's this one here. And we can see it's just a massive 2D array of variables or Unicode characters. So from there, it calls another function, which we're going to step into. And this is the one that we stepped into the first time, which shows a message box with a decoded custom error message that they have sort of faked. And depending on how long it takes to run, it decides whether or not to keep executing, which we sort of found weird, but it does it anyway. So let's just skip ahead through all of this. I'll put a breakpoint there. That might be a better place to put it. So we can see, yeah, it's decoded all of this stuff into the string MS Word, and we get a message box with the error message that it just decoded. We click OK, and we get some more garbage, and it just moves straight on to the next function. So we know I was going to try but it won't let me. I was going to try and sort of label a lot of these functions when I was prepping for the stream, but I didn't. So basically, we know this first one is just a message box. Going into the second one, I think we did this one last week as well. But it pretty much... So the one was the file system, like it's a special number for the temp directory.
Yes. So these are, so the particular function, what was it called?
The file system object function.
Yeah. So they're special shortcut numbers for certain directories. So like I think app data, user data, temp, program files, so that you don't have to go typing those in every time or dealing with, I suppose, the ambiguity of spaces. Or actually, It's also because, like when you're doing something and you get like %user data or %user % as the shortcut for C://
or like I
users,
just did there,
your username.
to open temp was %temp.
Yeah, so that's kind of what that's for. So, which can, again, is just another thing to make it harder to figure out what's going on. So, which is always interesting.
Yeah, so it's looking in this directory for a specific file, which was called, if I just keep going.
Oh, it had that random name.
It was it was Y something something something.
And if it found it, it just exited. So we got that far and figured that out. So one of the things with malware is, so that could have been there for two reasons. The first reason was either this thing, it doesn't like running more than once. So in a malware campaign, you might actually cop the same thing multiple times, but they only want it to run once. So if it was part of a spam campaign, which this was, because we saw this in a few different places, then you only want it to execute the first time because maybe follow-up executions break stuff, or your thing patches the vulnerability it's exploited, which sometimes happens. The other reason they do this sometimes, and especially with like the not Petya malware, where they, because this is what was his name, Marcus Hutchins figured out, poor guy who went through a bit in the US.
Yeah.
What it did was it looked for a domain that didn't exist.
Yes.
And if it got a response back, it meant it was running in a sandboxed environment designed to give. So one of the common checks you do when you're running malware is, can I talk to the internet? If I can't talk to the internet, there's either A, no use in me running, or B, someone's trying to analyze me, so I'm going to stop. I'm just going to die.
Yeah. And that's what could be happening here for us as well.
But that's easy to overcome with something that'll respond to every single network request your malware or virus or whatever you've got tries to send out, because it'll always pass.
Yes.
So then you have to go, and even if you try and do smarter things, like I expect this result from the server I'm talking to, someone can still go, you're trying to talk to this and get this result back, I'll just take that and copy it. So what you do in those environments is you then try and look up something you know doesn't exist as well as something you know exists. And if they both return true, then you're in a dummy environment, like a sandbox environment, and you should stop running. If the first one doesn't work, like you can't talk to the internet, then you stop running. And if the first one works and the second one doesn't, then there's a good chance you're not in the sandbox. The risk with that approach, as was found out from NotPetya, is all you need to do is register that domain, and now it's legitimate, and it stopped, and your malware everywhere in the world stops working, which was how NotPetya was stopped. Well, I think it was NotPetya.
It was
one of those.
Yeah.
It was one of those, like in that crypto locker scourge.
It was one of the crypto lockers. Yeah.
Yeah. Anyway, so this though is likely just doing a check. Beg a button to see if it's run before.
Yeah. So moving on, we're into another function, and this one's getting an object which has a bunch of methods associated with it. So it was calling the Windows Management Service, and now we've got an object in our code with a bunch of different functions that it can call under a certain privilege, which it doesn't actually tell us. It just tells us. I mean, we could look up what these numbers mean. But we're assuming it's probably the current user context, which would be an administrator.
I'm just gonna. You keep going. I'll do a bit of a.
You do a bit of the background research on what those numbers mean. So yeah, we've got a variable there with some Windows Management Service access, and now the next one that it creates is the actual query. So we can see here that it's trying to select star from Win32 computer system. And I'm not connected to the internet, so I can't actually Google that. But I think that one will give a list of executables running on the machine or files on the file system, something like that. From Win32 _ computer system. I should add another thing to this actually.
Looks like there are a few different contexts for authentication level. For WMI specifically, it's the authentication level to be used to connect to WMI. Was it an enum type?
It was a long.
It was a long?
Yeah.
I mean, that could still be an integer, I suppose.
Yeah.
Even if it was an enum.
Yeah, true.
Yeah. So 3, 2, 0, 1, 4, 5, 6. I think it was 6, maybe? Anyway, that just says packet privacy level Commonwealth.
The impersonation level was 3.
Impersonation level.
I'm just adding another captcha just so that I can alt tab between what I'm looking at.
Okay, cool. So impersonation level determines if processes owned by WMI can detect or use where WMI is Windows Management Instrumentation. I always thought it was Windows Management Interface, but it's Management Instrumentation, which is a bunch of like low-level APIs for managing bits of the OS. So this is whether it can also then leverage your credentials when making calls. So basically, can make calls on your behalf to other processes.
And 3 means it can.
It doesn't have the numerical values. It just has anonymous, identify, impersonate, delegate.
Right.
Okay, and impersonate enables objects to use the credentials of the caller. It is recommended to use this impersonation level with WMI scripts. When you do so, the WMI script will use your user credentials. As a result, it will be able to perform any task you're able to perform. So that sounds like it might be it, because impersonate's the lowest level that actually can do things as you. Otherwise, it's identify or anonymous, which don't. After that's delegate, which is where WMI processes can then grant privileges to be you to other processes. This all gets into like complicated authy stuff. Like these are whole. The difference between like impersonation and what delegation is are like whole things into themselves. But it just allows that to do things with your permission. So, and I'm guessing that's what 3 is. Anyway, continue.
Okay, so just looking at a couple of these, which are hopefully useful. So the next query that it tries to run is the SelectStar from Win32 computer system, which, I mean, we could probably run it ourselves. It looks like we can run it in PowerShell.
PowerShell.
Sweet. Good old Windows 7 PowerShell as well. Let's see if this works. What does that say? CIM instance. Win32 system. Okay, it doesn't work on Windows 7 version of PowerShell.
It might be, there might be multiple versions of, no, it was on, was it 8 or, no, it was 10 that had multiple versions of, no, maybe it was 8 as well, had multiple versions of PowerShell you could run. Because if I try that on my desktop, I'm on PowerShell. What was the thing you were running? I mean, not that anyone can see this because I'm doing it on my computer, but what was a get sim instance?
This one. Get hyphen CIM instance.
Instance or instances?
Instance.
Mine. Okay, yep. And then what's next?
Space Win32 underscore computer system. But the W is capital, the C is capital, and the S is capital.
I mean, it doesn't really matter. Okay, cool. So all that does is tell you that I'll send you a screenshot. Everyone will be able to see my username, but that's fine. It's nothing particularly special. I don't use it anywhere else. Actually, no, I will.
Let's do it. I can do it here.
Continue. I will briefly censor out one thing.
That's all right. I am going to do it here as well. So let's add a new source, call it PowerShell. This is how super organized we are at this stuff.
Also, trying to use paint to censor things.
All right, you should
just adds,
see mine now.
Just adds like an allure of quality to what we do.
So quality. All right, let's see what info this instance. Then it was Win32. No, it was just computer system, one word.
Okay, I'm sending mine to you. I beat you to it.
So it looks like it just dumps a bit of information about the computer. So
yeah, it doesn't actually seem to. Oh gosh,
the computer.
I just realized the difficulty in sending you a file is I have to turn off make the screen share small.
It's all good. I think I've got it running on the stream. Let me just have a look.
Of course, yes, you do. You do.
Sweet. Okay, cool. Yeah, so that is basically the result we should be after here. What it does with the result of that information, so we can see here it's got one row with a bunch of stuff in it. The raw view has just the context stuff in it.
Yeah, so this is probably a query object, like what gets returned. So
it looks like it is, yeah.
yeah, so if you go back up to that one that had the auth level and stuff, that's probably just telling you about the context the request was made under.
Yeah. Does it have the results of the request though? In 32 computer system property. This is probably the super interesting part for everyone. Let's just open all of them until we see something that's interesting. Well, that one's got that would be the computer name. If I just go here, it's...
The stream's still set to showing your PowerShell terminal, by the way.
Oh, crap.
Yeah. I'm doing my job.
Yeah, good call.
Yeah.
I forgot about that. Okay,
so the thing's now
just
starting to run a bunch of queries to figure out, like, to understand the computer it's running on.
Yeah. And so we can see in the same way that the query in my PowerShell returned, say, my computer name, we can see the computer name for this is IEWin7. And in this object, we've got that value. Where did I see it? Up here somewhere. There, IEWin7. So it's pulling a bunch of other data as well. And that's just for this. And when it queries through it, it looks like it's going to do a bunch of other stuff. So let's just minimize that. And this one is just one record in that list of results. Because the execute query would be executing that SelectStar. So this would be the results of the query. Plus int. So it's taking my memory, the computer total physical memory, plus whatever this value is.
Interesting. Dividing it by casting something to a long and something else to an int.
But that's itself, right?
Oh, so it's something equals itself plus something. Then it's obviously set earlier on as well.
It's not set anywhere else.
Interesting.
It's set in a very similar function, but it might loop back over here again and it keeps its value. Anyway, so yeah, it's looking at my computer's total memory, dividing that by the long equivalent of whatever these are, plus the int equivalent of whatever that is. So let's F11 in and see if we get anything cool. F5 to that, we get that number. That is not necessarily a number that means anything to me. It's not the amount of memory that this computer has or anything like that. So we'll keep going. The next one it calls is just the number 1, which is fine. So I'm not sure which order. I would assume that the 1 is the int and the convert to long would have been that 10 number. But basically we end up with...
So I forget the name of it, but the order of operations, I think the division would happen before the addition.
Which is interesting because the total value, the final value is my total memory plus 1.
Yeah, brackets, exponents, division, multiplication, addition, subtraction.
Yeah.
So
Okay.
bedmas.
Bedmus.
Um, so yeah, the addition would happen at the end. Why it's doing that, I don't know. Maybe that arrays something else. I don't know. Maybe
So
it's just generating some unique value for later.
yeah, I guess interestingly, the fact that it's the same physical memory plus one could be something that we need to worry about.
Maybe that other value is literally just. Oh no, but that's F8, F2, H9, J. They're the values from below, aren't they?
Yeah, they're these hard-coded constants.
Yeah, and but whatever that BPZ BEGV function does.
That was the decoder. So that was decoding these numbers into a string, and that string was like 10 something something something, and then it converts it to a long, and it converts that into an int.
I
So if
I am
we
mystified.
if we took 192 as a Unicode character and then converted it to an int, it was probably like the number one or something. I think that's my understanding of what's going on.
All good.
So now it is, let me just minimize that. Now it's checking to make sure that if the number it came up with is less than this, so we'll get to see this in action here. So F11ing in, our number here should be that 192, which is this here. So we've got 192, 191, 193, 195. It is, yeah, so the CHRW is converting that to its Unicode character equivalent.
Minus 143.
Minus 143.
Yeah. So it's yeah, because the number one is actually 31.
And yeah, so we can see that that equals this number, this string here is what we're interested in, and that just equals the number. So the first one is 1. Then if we just F5 so we get to the bottom, we get 1024. So all of these numbers here, minus 143, equate to the characters 1024. So that's basically checking if whatever it was trying to figure out there, something to do with my total memory, is less than 1024, which is probably a gigabyte in this case it's thinking.
Or, given it's doing divisions and adding 1, it's trying to figure out if it thinks you're on a system with real RAM or not. So, because real RAM generally comes in divisions of like 128, 256, 512. So if it doesn't divide evenly into that, they might suspect you're on a system. So if you set your RAM arbitrarily to 3.5 gigs, it might go, hang on a second, that doesn't divide neatly.
Right, could be that, yeah.
Yeah. So it could just be a check, like another preventative, I think I'm running in a VM check.
But then it's doing if that number. So here it's saying if 7168, which is my current memory, which is 7 gig, is less than 1 gig, then we want to run that useless waste of time function 3 times.
Oh, okay.
So that could be, it could just be to fill memory, that function.
Maybe. I don't know. It seems weird to do that when you don't have much RAM, though.
Yeah. So overall, again, the point of this function is pretty unclear because it ran a bunch of WMI queries to figure out how much memory I've got and then not really do anything with it.
Yep.
So the next function, it looks like it's going to do a similar thing again, but this time we've got the query, or we've got cis.exe, which I'm not sure what that is. It's probably a Windows built-in.
So what was that?
cis.exe.
cis.exe. Ooh. CIS.
While you Google that, I'll keep seeing what's going on next.
You know, the annoying thing about the Omnibar is if I try and search cis.exe, it's going to give me a DNS error. So I have to actually type Google into the Omnibar to then search Google for something. It's
if you type at, so you can do like at DuckDuckGo, and then it will search whatever you type into it.
Okay. That's okay. So it's searching for Komodo Internet Security.
Interesting. So the next one in the list is cmdvirth.exe. I don't know what that is. That's probably another antivirus or something.
Komodo Virtual Service Manager.
Yeah, okay.
Yeah, so they're all...
it looks like what it's doing is potentially looking for a bunch of known antivirus softwares.
So one of the things you do is... so AV normally kicks up alerts. If an alert gets kicked up, something might have gone wrong, especially in an enterprise context. Everyone has like McAfee EPO and the enterprise security, whatever it's called, or for any number of vendors, and they're all normally integrated. So if your thing detects an antivirus and dies before it actually runs, then there's a better chance of your attack being undiscovered. Whereas if you let it run, it might light up everywhere. So
yeah, so that, I mean, it just looked for Perl.exe.
alive is just a... that's... Why did it just open up a...
Process Explorer,
text file?
ping.exe, auto run.
alive pings hosts and returns an error level indicating success. So it might just be looking to see if you've got certain things installed.
It is looking for a lot.
Yeah. So it looks like it's AV. Some of the stuff there is just normal utilities that aren't AV. Immunity debugger, yeah.
Yeah, so it's looking for potentially reversing tools like immunity. It was looking for OllyDB before, or OllyDebug before.
So things that people might be running to detect and reverse whatever's going to happen.
Surely Visual Studio's on this.
Info client, proc mount. But some of them, taskmanager.exe is standard.
Python.exe.
But it might be CTF Explorer, IPFS, Python W, TCP dump, QQ, TCP view. Why it's doing this is a bit of a mystery, but I could think of a few different reasons why. It's either because it's just wanting to find out what they are used for and then make decisions on that. Because I couldn't imagine because some of these things would be useful if you maybe not. Maybe it is just looking for things and going, no, I don't like what's on this.
But things like Python and Perl would be useful for it.
Well, but Python and Perl would also potentially indicate you're on a device that someone's using for like reverse engineering purposes.
True. And yeah, a lot of these tools aren't installed on this computer either. So it's not pulling these from the results of any of the like WMI queries or anything like that.
That looks like some honeypot stuff, maybe fake server and fake HTTP, Fiddler. Yeah. Well, except now you've just basically ruled out every single dev box like the developer might be on. Okay, we're through. There might be something on this box that this doesn't like.
I think I just accidentally skipped over a line, yeah. But now it looks like it's doing a similar thing. So it's running those queries again. It's just getting the object. So the similar way that it did just before. So this one will most likely again be a WMI query. Yep. So this is probably, yeah, so it'll select all of the current running processes now and probably try and find if
Any of them
running
are...
processes are in that list that we just had.
Yeah.
So
Because
I
that'd be it, is
wonder,
if Python's currently running, it might indicate you're running some of the Python reversing tools.
yeah, so if
So
name is that, then do this.
waste time.
Just waste a bunch of time. Awesome. What we should be able to do though is for each this in this, can I modify this array? No. Well, that's annoying.
Wait, if you go edit value and actually type something, and then go enter.
Aha.
Yeah.
Okay, so what do
Pity
we...
you can't delete values.
Yeah, what do we think I've got running on this? Because I can just put copy paste.
Wireshark could definitely be one.
I don't know. Yeah, let me make it a bit bigger.
And this is why this stuff in scripts can be difficult, because observation. So this is one of the like things in PowerShell land, which is probably a more recent way this sort of stuff would get delivered. Actually, maybe not, because PowerShell has a whole bunch of alerting and stuff on it, whereas especially more recent versions of PowerShell, whereas this wouldn't. But in the PowerShell world, you can try and munge up whatever you want, but at the end of the day, it's quite easy to see what was really being run, and it's the same here. It's not too difficult to figure out what's going on.
Yeah.
So we can go and...
None of these look like they're built-ins that I've got running.
Yeah.
We went up to Azura. What a screenshot snoop. I don't know if that's just talking about anything.exe, so I'll just replace it anyway. Auto run.
It could be an error.
It could be
something.
It could be an error in the decoding, yeah.
Or not in the decoding, in the writing. If it was just chucked in there.
Yeah.
Yeah. If it's doing a direct match, it won't work. But yeah, they all look like...
System Explorer is not a default, is it? No.
Do you have that running?
Nope. Or unless it's that, but that's not an executable. That's
no. System is the kernel, mate.
Yeah, exactly.
I know that much about Windows. System is Windows.
Those. Procmon I was almost running. That's that process monitor. Task Manager I'm running, so I'll just get rid of that.
Oh, wait a second! It didn't remove it.
There we go.
There you go. Yeah, so it's like looking to see if you're trying to spot it as it's running. Yeah. TCP view. Maybe the PCAP ones as well, because Wireshark behind the scenes might run some stuff.
Yeah, true. Where were they? TCP dump. No, it's not running TCP dump. Does Wireshark use it? Don't know.
Actually, go back to Task Manager. You should be able to view subtasks. So if you scroll down to Wireshark, W, mate.
Probably have to go over to this one.
That's right, Resource Monitor.
Yeah. So it's a shame that I can't. I can resize it. Sweet. Well, there's perfmon.exe anyway, so
you'll have to get rid of that.
Dump cap. I think I feel like I saw that somewhere in this list too.
Yep.
Oh man, how many are there? 130. Can I just like enter? No. Damn it. There's no hotkey for modifying the file either. Modifying the value.
There's Wireshark though.
Sorry, this could take a while and be a bit boring. It would be nice if we could just delete the values from the array. Or do like
maybe it doesn't let you, depending on the context, because of the way stuff gets allocated.
Damn it.
No, yeah.
I can't just select them all and say set them all to this. You know what I could do?
Yeah, so
I could change this value here.
Will that work, or is C script already got everything and just sending you the debug stuff back?
No, but I could stop debugging, just change it, and then debug, like jump back to this point again.
Yeah.
That might be quicker.
That's probably quicker. Yeah.
Oh crap! What line number was that?
You had a debug symbol on it though.
Yeah, but I had one on all of the functions. Quick, live stream. What line was it? 643. Haha.
Oh, you went back and had a look.
Wait, that's not. Oh no, that's 800. 643.
Jeez, mate. Get your font sizes right.
Found it. So if we...
Don't forget you'll have to delete that file as well.
The one
that gets created.
Temp. It hasn't done that bit yet.
Oh, okay.
So we haven't got to the part where it creates that file yet.
What are those other file munged up file names in there?
Oh no, it has. Like yeah, you're right. There it is.
Yeah, and the other three below it that are the... Oh, okay, no, they're actual file types.
Doesn't matter, deleting them anyway. Okay, so we want this to be an array, but let's just call it an array of the string test. Because it's expecting an array to do this loop, so it should only loop once and we should be right to go. Make sense? All good? Should be fine?
Have you... Oh, yeah.
You know what? It's too late now anyway. Let's comment that line out. Did I just balls it up? No, I didn't. Cool. Okay. Tools. Yeah, I did. Debug with that. Cool. Let's just F5 past all of this because we've seen all this before. We know that that's fine.
And that's probably a prompt to... When the next unit pops up, the user's got a little bit of buy-in as to, oh, Word's not working, and then they'll go, hey, go here and do this.
Yeah.
I mean, this could all be a fancy script to open up the web browser on a phishing page or something.
It very easily could be. So now that we've modified the code to hopefully bypass their little file check, we should see in here that will most likely be a list of all of my running processes. And now this is just the string of text, which is what we wanted. It doesn't equal vac.name.
Oh, it's 2 for eaches, yeah.
Which will be in here somewhere. So one of these will have a name.
There it is. Oh no, that's just path.
It couldn't be that one. Name space.
No, this is the wrong bit. Yeah.
Anyway, whichever part of this array it's looking at, it won't be in there. So that's cool. We skipped all of that.
Yeah, so last week we found out that function just does maths for a very long period of time.
Yeah, it just does a random amount of maths. So now that
Maybe
we've
it's
done
trying to
that,
calculate something, but we couldn't tell.
it could be, in terms of debugging and like Wireshark and stuff like that, it could just be to create a boatload of noise just to sort of make it more difficult to
Yeah, or it could be
analyze.
there to waste time, and later on there'll be another check that fails. Yeah.
True.
Um,
This function could potentially be doing a similar thing again. This time we're worrying about the number of cores. So I think I gave this one 4 cores. So looking into this array, we end up with the value of 0. So that equals 0. Then we're going to run the query against WMI 4 F5 SelectStar from Win32 processor, which obviously probably does exactly the same thing where we saw about the computer details, but it probably gives details of the processor itself, so the name, manufacturer, all that kind of stuff, and the value of 48, which I'm not sure what that has. That'd be this here. So execute that query, and with the second argument of 48, whatever that argument does. Now for each of those results, throw an exception. What's the exception details? Awesome. Thanks for that. Great detail. Should we look up what this exception is?
yeah, why not?
SWBEM object set exception. And let's just swap over to where are we over here? I think I called it this. Transition. There we go. So that's nothing useful. That's not useful at all. That has nothing to do with the exception. So we know that it was executing query SelectStar from, it was Win32 processor.
Yes.
With the number 48. With the second argument of 48, I should say. If I just look for the number 48, that's not what I'm after. That's not what I'm after. Alpha family is the value, or that is the value. Could that be the specific type of manufacturer for like VMware? Let's see.
Well, so with virtualization, your CPU should be passed through in a way that it sees your actual CPU.
Yeah, that's what I would have thought. If I look at this, yeah. Yeah, so that is my processor on my host. It's just 2 cores, 4 threads. So something about this through an exception for each that in MX. So MX has... Can I no longer view
Nothing.
it?
No, it's empty.
So MX is empty. So this query returned nothing as a result. And that's why it's throwing an exception. Because it's no longer a list of stuff.
If you run it again but assign the BPZ BEG thing to a variable, you should be able to see what the value of that variable is as the error is out.
This one?
Yeah. Oh, did you already figure out it was doing that Win32 processes?
Yeah, so it's running this execute query SelectStar from Win32 processor, and it's got the second argument of the number 48.
So what was it? I'm just going to do a quick PowerShell. So, the object. What was the name of the query?
Win32 underscore processor.
So what that returns is, caption, which is for me Intel 64 Family 6 model 158 stepping 10. Device ID CPU 0, manufacturers genuine Intel, max clock speed 4008. Name Intel Core. Yeah, that's just my CPU model. Socket designation U3E1. That's all it returns. So if you have multiple physical socket processors, it sets something to true.
Is that not how you run a query? Is it just... No? As someone that's never actually used this tool in the command line, I'm just trying to figure out how to use it, how to run a query. Okay, to none of those. It's none of those. It's none of those. Query. There's no query or select or... Has anyone actually used this before? How to run a WMI query from the command line.
There's nothing like learning in real time.
Yes, and I'm trying to make it as quick as possible.
In PowerShell, it's quite easy. You've just got those get WMI object.
Yeah, but this one doesn't have those because of...
Yeah, well, because this is specifically you're using WQL syntax.
Yeah, true. Come on, internet, go faster. How is there not just like a command line way of running this stuff? Like running literally the exact same queries that they just tried to run.
Oh yeah, WMIC doesn't look like it uses WQL either.
This reckons run WBEM test. Okay, that's a thing. Click connect. Cool. Change that to that is fine. Enter the domain user and password. So that'll be iUser. Let's type that. None of this is a secret.
I like it how your password's all asterisks.
Oh,
there's
really
the impersonation level. There's
Sorry?
the impersonation level from before.
Oh yeah, right. So it's probably 1, 2, 3. I would assume it's 123.
Oh no, there's anonymous as well, which this probably doesn't let you do, but because you put in creds.
Cannot be used for local connections. Maybe I have to do delegate. No. Well, it's not running as me then. Wait, am I IE user?
Yeah.
Do I have to do like the domain? Is it?
The other alternative is I figured out how to do queries and proper queries in PowerShell.
Yeah.
So if I PowerShell back up,
Yep.
and just go once it fires up, fire it up. $, and then just query will create a variable.
Yep.
$query. Just type the word query. Well, no, up again because there's more to that line. Equals, and then double quotes. Select star from, and then was it Win32 processor?
Yep.
Okay. End quotes. Right, and enter. Now, get-wmi object, and then dash query, and then $ query. Oh, it did an error.
Oh, I think it did. Oh no, that's fine. Cool. Okay.
Yeah. I have a feeling maybe it just got more back than it was bargaining for, maybe?
Well, what's the 48 got to do with it then? So, I mean, 48 here is the property count. I wonder why this has nothing in it then. Maybe we just do...
If something number of cores is less than some other value, then something equals true.
Okay, so we were on line... I did it again. 612. So rather than do a for each loop, if we just do if 4 is less than whatever this is.
Yeah. Nice. Don't forget to delete that file.
What's that value?
Ugh.
Oh, that's this value up here. Okay, right. All right, let's have another hit at it. Temp. Hello, file. I want to delete you.
Oh, it's not there. Cool.
Yeah, that's weird. It was there last time. Okay, let's run it again. So I didn't mean to say that. Let's go. We're up to line 612. Oh, it's not corrupt. We swear. Didn't create the file or something. No, nothing's wrong there. Do you reckon that's not... Let's just do that.
Maybe.
Maybe it doesn't like just a hard-coded number.
Maybe it's insane as JavaScript.
It is possible, and I'm just going to dump a bunch of them so I don't accidentally F5 over it. Because I got a lot of F5ing to do. Skip.
Oh.
Nope. Failed to connect to the target process.
Undo until it's back to the way it was, just to check that it's something you've introduced.
Well, that was just to that.
Yeah.
No.
No,
So it's not
it's
something that I introduced necessarily.
maybe you need to do a reboot. I don't know, just to be on the safe side.
Okay, we were on line 609. So, because I'm going to lose all of those debug locations. It didn't create that file because it crapped out. That's fine.
Well, we're just past an hour as well, so
Okay, that's fine. We'll figure this bit out, and then we might have to call it, and we'll hopefully have something more useful next week. Put that in. Let it think. Let it think. Oh boy, that is slow. Okay, line 609. There's probably a hotkey to say go to line number, but I don't know what it is. Come on.
while we're waiting, I'm just going to have a quick look and see if there's any interesting news.
Yeah, good idea.
Apple in China, they're using Tencent. Tencent. I don't know how to pronounce it. They're like a massive Chinese company that does stuff. They're using them for dodgy URL checking in China.
Okay.
But the way the URL checking works is they may log your IP address. So effectively, Google is who they use in the West in countries that aren't China. So you go to a website and it'll check with Google to see if it's sus first, which means effectively Google knows everywhere you go because they can just record your IP address as well. If you've logged into Google anywhere else, they've matched your IP address to you and they know where you're going. You'd hope they're more ethical than doing that, but Tencent's doing the same thing, and there's some concerns that they can now do this and see where users are trying to go on the internet because Google's blocked effectively in China. So this was Apple's way around it, but the challenge there is that Apple didn't disclose this. Normally they disclose small changes like this, but they didn't disclose it. And there's no understanding of the limitation if it's just in China or if it's like everywhere it's possible.
Right.
Combine this with if there was some flaw that you could trick everything into talking to Tencent instead of Google. I don't know.
Tencent have that sort of reputation of being a dodgy company as well, don't they?
Basically, and please don't ban me from the internet, China, but every Chinese company has some interest. The Chinese government has some interest in them. So, are you just doing a safety repair as well?
Yeah, well, it still didn't debug, so I think we might have to call it there for the week and try and figure out what's going on, and rather than waste everyone's time even more.
Start from scratch. I mean, we got through an hour. We learned a little bit more about how this thing runs. Next week, we might do something else just to change it up and then get back to this.
Yeah.
So that it's less, not just us poking around a script the whole time. Maybe next week we'll talk about the reversing challenge we did as well.
Yeah,
and maybe
that's
see
a good
if
idea.
anyone is up for it. So we might leave it there. Have a good one, guys. Stay safe.
Thanks.
Keep it real.
We'll see you next week.